Hi, my name is Valeria, and for my Trig class project, I'm going to model 3 real-life situations in Evanston using trigonometry. Before starting, an important equation to keep in mind is the general equation for sine waves. It goes y equals a sine of b, x minus h plus k. A is the amplitude, which represents the height of the sine graph divided by 2. B is the period, which is the cycle, one complete cycle of the function. H is the phase shift to the right or the left, and K is the movement up or down. Now, the first example is a Ferris wheel. I have to write a function that will show the height of a person starting off at the lowest point after t seconds. Here's what we know about the Ferris wheel. It's 10 feet off the ground. It's 140 feet tall, which means that the radius is 70 feet. Since this is the middle of the circular motion of the Ferris wheel, the axis of wave is y equals 80. It's 10 feet off of the ground and 70 feet up, which gives you 80. The amplitude is 70 because it's the height of the function divided by 2, aka the radius. The period is 7 minutes. We know this because another piece of information that I didn't say before is that one revolution of the Ferris wheel happens in 7 minutes. And in modeling sine and cosine functions, in modeling real-life situations, you can either pick the sine function or the cosine function. In this case, it'll be easier to pick the sine because that will involve a phase shift right or left, unlike the cosine function, which will involve a little bit more work. So, if we model it as a sine function, we know that the period is 7. So half of the period is 3.5 minutes. And half of that, 1/4 of the cycle, is 1.75 minutes. This point right here represents the lowest point that the person is on the Ferris wheel. So, but now it's at negative time, so we have to move it up to 0. And the way to do that is to shift over 1.75. So we know that the phase shift is 1.75 to the right. Now, based off of our axis of wave, which is the line that goes through the middle of the function, we know that it has to be at 80 feet because that's the middle of the Ferris wheel. So we have to move the function 80 feet up. So it's going to have a movement of up 80 feet. Now, another important point when substituting these values into our general equation for sine waves is that you calculate b you calculate the period by dividing 2 pi by b. And we know our period, which is 7, and we have 2 pi, so now we need the b to substitute back into the general equation. We do 7b equals 2 pi, and then divided by 7, and that gives you b. So now we have all of the elements that we need to fill in the equation. Y equals a, the amplitude, times the sine, and then we have b, 2 pi over 7, times x, and since the phase shift is to the right, we're going to subtract 1.75. And the last element is plus 80, because we know that it's moving up 80. And this right here is our function. We plug in x, the number of seconds after the person starts at the lowest point, and we get their height. Thanks!